Now we'll see about scoping rules in R programming, and what are they and what exactly are they used for. So how does R know which value to assign to which symbol? When I type, let's say lm a function of x star x. So how does R know what value to assign to the symbol lm? Why doesn't it give it the value of lm that is in the stats package? So there are like multiple stats package where this lm variable is declared and used. So I'll tell you later how do you bind values to a particular symbol. So when R tries to bind a value to a symbol, when it tries to assign a value to a symbol, it searches through a series of environments to find the appropriate value. When you are working on the command line and you need to retrieve the value of an R object, the order is roughly like it searches for the entire global environment for a symbol name matching the one requested. For example, the lm that is used in the previous program, it will be searched in the entire global environment before matching the one requested. And again, next thing is a search the namespaces of each of the packages on the search list. Namespaces are just list of all the variables or functions used in a particular package. It will be given in the search list. So again, you can use the search function to extract the search list. For example, if you use the I'll show it in the R module. So if you use search, it will give you the packages available in R programming. Global env, package stats, package graphics, package GI devices, package utils, package datasets, package methods, auto loads, and package base. So these are your packages available in this search list. So this list will be searched whenever you are assigning a value to a symbol, and this symbols will be searched in the namespaces and this search list. So we are seeing this binding values to a symbol. The global environment or the user's workspace is always the first element of the search list, and the base package is always the last. The order of the packages on the search list definitely matters. As you can see, it starts with the dot global environment and package base at the end. So every search list will start from here global environment to package base, and the search of each namespace will start from this to this. So that's the reason the order of the packages on the search list matters. So users can configure which packages get loaded on startup. So whenever you want to, whenever you are working on R and you want to start using, this is nothing. If you know C programming or C++, this is same as using include the library files, include variable in C++. So you cannot assume that there will be a set of list packages available. So when a user loads a package with library, the namespace of that package gets put in position 2 of the search list by default, and everything else gets shifted down the list. So for example, you are loading a package from the library, so it will put next to the global environment search list, and position 2 of the search list will be occupied by the namespace that you are using in your program, and everything else gets shifted down the list. And you can note that R programming has separate namespaces for functions and non-functions. So it is possible to have an object named C and a function named C. So you can have a the naming can be same, but the characteristics can be, it can be either an object or it can be a function, and it can be stored in multiple locations. For example, if you have an object named C, it will get stored in others, but for functions it will get stored in methods. What are the scoping rules? So the scoping rules of R are the main feature that makes them different from the original S language. So they determine like how a value is associated with the free variable in a function. So they use R programming uses lexical scoping or static scoping. Common alternative is dynamic scoping, which I'll explain you later. Related to the scoping rules is how R uses the search list to bind a value to a symbol. So lexical scoping turns out to be particularly useful for simplifying statistical computations. So you have a function called f, which has arguments x comma y, and it performs the following things: x square plus y divided by z. So notice that z is not available in the argument list. So this function has like two formal arguments x and y. In the body of the function there is another symbol z. So in this case you can call that z as a free variable. The scoping rules of a language determine how values are assigned to free variables. Like the scoping rules are nothing but it determines the scope of each and every variable. Where does z actually come from? Is it within the function? For example, the variables x comma y, the scope is within this function. Free variables are not formal arguments. You cannot put them in formal arguments, and are not local variables. Which are local variables are here. The example, the local variables are x and y, which are assigned inside the function body. So z is actually a free variable which will be declared elsewhere apart from the function. So it will be stored in some kind of objects or function depending on what it is. So lexical scoping in R, it means that the values of free variables are searched for in the environment in which the function was defined. We'll see the example that we saw earlier. So let's say I'm defining a variable called z. It's done. So now I'm creating a function called f function of a comma b, and here I am declaring a plus b plus z, and I'm closing the function. Now this function has two variables a and b. So if I am passing f of 2 comma 3, it will give me 10 because a plus b is available within the function, the scope is within the function, and the value z, it is declared from z equal to 5. This z will be stored in any of the packages above, the base package mostly. So the environment variables it will be in the environment. Lexical scoping in R, it means that the values of free variables are searched for in the environment in which the function was defined.